Okay, we're recording the lesson 42 for today's class, Monday, October 29th. And remember, by the way, um, we have our test on Friday. We'll have a test Friday, right? Because we'll be done with lesson 43 on Tuesday, lesson 44 on Wednesday, lesson 45 on Thursday. And then, of course, after any multiple of 5, we have our next test. So our test A, 8A, will be on Friday. Okay, so just write that down if you need to remember that, and we'll be good to go. So today, listen, we're talking about repeating decimals. It's not a very difficult concept, actually. It's one of the easier concepts that we'll be doing towards this second quarter. Looking at your book on page 302, it gives us an example of 43 divided by 6. Actually, it shows 43 being divided. It's actually 43.000. It goes out quite a ways. But the bottom line is the answer when you do that is 7.1. 6, 6, 6, 6 keeps on going out. So typically, when we divide something like when there's a remainder of 0, when you take 12 and you divide it by 4, obviously 4 goes into 12 3 times. That's 12, so there's a remainder of 0. Whenever you have this remainder of 0, that's called a terminating decimal. I'll write that down. Sounds like a good test question. Terminating a decimal. That's what we call that. Because it terminated, it ended. There was no remainder, nothing left over to have to carry up there and divide and bring it back down and multiply it again and subtract. We're done with all that. It's all done. The problem has been solved. The answer is 3, which we can also say that it's actually 3 or 3.0 if you wanted to put a 0.0 there, the decimal 0. But this one up here that we're looking at, a little bit different. We divide 6 into 43. You get 7 times 6 is 42. You have 1 left over. You have to bring down a 0. That's where this one up here comes in right there. And you times it by 6, and you get 4. You bring down a 0, and you get 6. And you get 36 with the remainder of 4. You bring down a 0. You get 6. So this is a repeating decimal. What's repeating, of course, is the 6. It's in fact the 6. So when we write this, you could write it 7.16, and you put that repeating bar over the number that's repeating. You would not put it over the 7 or the 1, of course, because the 7 and the 1's not repeating. And by the way, the repeating bar never goes over anything to the left of the decimal. It's always to the right of the decimal. So it never goes over this way past that decimal point. There's no need to put that repeating bar over all the 6's, because you're just simply saying that 6 continues to repeat, which means, in fact, if we were to do the math, it would just keep on going and going and going and going. Okay, so that's our new concept. Any questions with that? Well, before I ask you, let me make sure you understand this. If we have 0.31818, make sure you see my decimal point right there. That can be written as 0.318, and we put that line over the 1 and the 8. You see that? Because the 3's not repeating, but the 1 and the 8 and the 1 and the 8 repeats. So we don't put it over the 3. We just put it over the 1 and the 8. Everybody got that? Okay. Julia? If you had 3.18, so if I'm going to put it over here in a different color. Let me do this one. So 0.31818, and then did this. Yeah, it's not that it's wrong. It's not right. You still mean the same thing, but the shorthand really is to not to have this here. And so we get rid of that, and then it would just be doing it the right way. It would be over the first 1 and the 8 that we have. Okay, that makes sense? Yeah, Tanisha? Say that again? Yeah, as soon as you have the numbers that are repeating, that's where you would put your repeating bar. Now, as I said, we know that the 3 is not repeating, so there's nothing goes over that 3, right? We don't put a bar over that. But the 1 and the 8, this is our original answer right here, 0.31818. So the 1 8's repeating, so that's why we put the repeating bar just over the 1 and the 8. And it is correct to put it under where it repeats the first time. Otherwise, you can have 0.3181818 and then put it over here, but by doing that, you're implying the 1 8 repeats, so why not just put it here and get rid of all this? Okay? London? Okay, so they're throwing something new at you. Throwing something new at you. Any more questions on this page before I get rid of it? Okay, I'm going to clear it out, and we'll start over again. You didn't do this last year? Okay. All right. Well, it's not a difficult lesson, though, is it? I mean, it makes sense. Does it make sense? Are we okay? All right. Okay. All right. Well, so let's do example 1. And example 1 wants us to rewrite each of these repeating decimals with a bar over the repeat end. So we have, up on the board, we have letter A, and it's 0.0833333. Maybe some more there. But it wants us to put the repeating bar over the repeat end. And what would the repeat end be here? Do me a favor and turn the lights out. Go ahead and turn the lights out. Yeah. What is it? Go ahead, Emma. Yeah, three is the repeat end. So when we're putting this answer up, then we obviously would not put it over the 8. Would you agree? It would simply be over the very first 3, 0.083, and there's my repeating bar. Would somebody go up there and turn that microscope off? It's on the button should be on the floor of the microscope on the right side. Little toggle switch. Thank you. Another one there too, I guess. Oh, there's 3 of them. Oh, they're all on. Blurred. Would you please? It's hard to explain. It's on the base of the. All right, guys. Let's stay focused on the lesson, please. The next one, let me get a better, maybe a color it's easier to see. I think the yellow would be easier, maybe. We have, this is a long one. Wow, I got to write this down here. B, it's asking for 5.14, 2857, 2857, 1428, 142857, 14. Alright, so you're looking for a pattern here, and we can see that we have a 142857, 142857, so you can assume that it's going to be 14, and then if you had to guess, you would say that this is going to be 2857, right? So to write this, the repeating bar over the repeat end, what would it be, Julia? Huh? Above the 7? Here? What number, but what number or numbers are repeating? Okay, so we would put it over the whole thing, right? That makes sense? Everybody see that? Because this number right here is the same as this number right here is the same as this number right here. So we're saying that this number, this whole block of numbers right here is repeating. And so this is the repeat end. This is the repeating bar. Notice nothing is going over to the left of the decimal, right? Nothing goes over that. Are we okay with that? Okay, I'm going to clear that out. Okay, so you know what? What'd you say? Okay. Okay. So now you get it? All right, that's the important thing. So we have this one here, 454.5454. Then your book says 545. So obviously, who's sitting there? Is that Paulina? Who is that? No, it's Emma. Okay, Emma, what's up? You gonna do this one for me? Okay. I could add a 4. I mean, I kind of know that's repeating there, right? I mean, so it goes over the repeating bar goes over the 5 and the 4. So the 5 and the 4 is my repeat end. Now, why didn't I put it over here? Yes, it's to the left of the decimal. It never goes over there. Very nice. Good job. Everybody understand that? Great. Yes, question? Here, there is no decimal. I mean, there is no 0. There's a decimal. There is no 0. No. Yes? It throws a 0 here and a 0 here. Okay, well, okay, so, but what if? But what if? What if I had 454.054545454? Look at the repeating bar still goes over the 5 and the 4. It does not. I do not put it over the 0. So my answer would be 454.054, repeat end over the 5 and the 4. Okay? Make sense? Everybody understand that? Does anybody not understand that? And it's okay if you don't understand it. Don't be afraid to say, I don't understand. Everybody's got it? Okay, I'm clearing it out. Speak now or forever hold your peace. All right. I'm taking your word on that. Here we go. Example number 2. Round each number to 5 decimal places. Here's what they're giving us. And this is letter A. You guys want the lights on? Okay. You can't sleep when the lights are on? Okay. I thought you said you can't sleep when the lights are on. Remember, this is being recorded. Oh, yeah. Yeah. Who's sleeping now, huh? Let's see, Mr. James, that was London. That was London. London's mom and dad, if you're watching this video, your daughter's sleeping when the lights... Okay. All right, guys, let's get back on track, please. Hello. Ladies. 5.316. This is the problem we have in our book, and it's giving us this. It's got the repeat end over, the repeating bar over the 6. So it wants us to round each number to 5 decimal places. So what is the first thing I probably want to do here to make this happen? Now, when it says 5 decimal places, do we count this 5 as one of the 5 decimal places? Listen, anything to the left of a decimal is not considered a decimal place. Decimal places are only to the right of the decimal. So we do not count this in our quest of going to 5 decimal places. The decimal places are this way. There is a decimal point, and The decimal places are to the right. Okay, so we have to make, they want us to round this off to 5 decimal places. So let me rewrite this to 5.31, and then what's repeating? The 6, right? So I can just go 6, 6, 6, 6, 6, as many as I want, and they want me to go to 5 places. So as I'm looking, it's like there's 1 place, there's 2 places, there's 3 places, there's 4. There's my 5th place. So this is where I have to write this out to, but it said, let's see, what did it say? Round each number to the 5th decimal place. So I'm writing this as, this is going to equal 5.31. That's 1, 2, 3, 4. This fifth number right here, let me give it a different color if I can. This fifth number, this missing number, has got to be rounded either up or stays the same. So I see that it's going to be a 6 again, obviously, because the 6 is repeating. And according to the rules of rounding, would that 6 stay a 6 or would it go to a 7? It would go to a 7. So that is my answer. That is the way I would answer. That's how I would answer that question. It would be 5.31667. Okay? And now I don't have a repeating bar anymore, do I? I rounded this up so I don't have that 6 going on. Anybody have a question about that, London? I would not, no. No. Nope, I am done. If I add a 0 over here now, that wouldn't be the proper way to do that. And they're not asking me to do that, so we don't have to worry about that. The accuracy right now is to this point because we've rounded. Emma? How do we know? Okay, remember when we're rounding, let me write this here. When we're rounding, if the number is 0 to 4, the number that we're talking about stays, right? Remember that rule? Stays the same. Let me scroll up here a little bit. Hang on. If the number is 5 and up, then the number goes up 1. Remember that? So if I have 4.36 and I want to round this into the tens place, that would be 4.4, wouldn't it? But if I had 4.33, it would round to 4.3, right? Okay, any questions on that? All right, I'm clearing it out. Huh? That's example, in the book, that is example 1, 2. Example 2. Example 2. Okay, let me clear that out here. Our next example is rounding to 5 decimal places this number, 25.405. Okay, so I'm rounding to 5 places. I already got 3 right here, so I'm just going to recopy this to 25. By the way, actually what I probably should have here, just so you know, in the book, this is what it is, so we know the 405 repeats. So I'm going to put 405, 405. Y'all see why I did that? Because the 405 is repeating. And I have to go over 6 places, or 5 places rather. There's 1, there's 2, there's 3, there's 4, there's 5. That's the one that's going to determine which way, that's the last one, last spot in my answer. This number here is going to determine if that 0 stays a 0 or becomes a 1. And because of the rules of rounding, Emma, what is that 0 going to be? Is it going to stay a 0 or be a 1? It's going to stay a 0? So it's supposed to be 25.40540? No? Emma? I'm asking Emma. No? What should it be? Why? This is the number this is my 5th number, right, Emma? And the number to the right of that determines if that number stays the same or goes up. Okay? What's the rules of rounding again? Hey, I'm asking Emma, folks. Emma, 0 to 4, it's the same, correct? If it's 5 and up, then it goes to the next number, right? No. No, because that doesn't matter. It's based on the next number. If they want you to go 5 decimal places, you have to look to the 6th decimal place for what that number in the 5th spot's going to do. Does that make sense? Does everybody understand that? Are you sure? Okay. Is anybody confused? Okay, Chelsea? Well, and that's true, but what's driving that answer is the fact that when we're rounding, we have to go to this 6th spot. It's asking us to go to 5 places, and these are the 5 places right here. And the last place is determined by the next number. This number doesn't get to make it into the problem, but it determines what that last number is going to be. Right? Okay, so we're okay with that now? Chelsea, are you okay? All right. All right, guys, let me clear this out. And make sure I scroll all the way down. There we go. All right, we're at example 3. It wants us to do this comparison. It wants us to compare 0.3, and there's our, let me get a different color here for our big circle like it always gives us. Wants us to compare 0.3 with 0.3 with the repeating bar. So I can write this another way if I wanted to. How can can I just do this? Can I just put this as 0.30? And then have my big old circle there, and then have 0.33? Which number is bigger? So would you agree with that then? Who says no? Okay, Catherine, is that you? Okay, why do you think that 0.30 is not less than 0.33? You see it? Hey guys, and the way you want to do this, look at the way you want to do this, you want to make sure that to compare, you want to make sure that however many decimal places are on one side of the problem, you have that many on the other. So when you have, you know that when you see 0.3, you know it's 0.33, right? So but you want to write that down, and actually this means 0.33 to infinity, right? Forever. But if you write down 9 3s, then really to compare it right, you have to write down that many zeros. But it doesn't really matter, right? I mean, you go by the very first number, which happens to be a 3 and a 3, so it's even. As soon as you get a 0 here and a 3 here, this side's greater. Okay, the next number is it's like these two guys are fighting each other. There's a tie. These next two guys are fighting. Oh, 3 wins. 3's greater. So you just keep on going down the line until one number is bigger than the other. Right? Okay, now let me make sure you understand this. Uh-oh, do I want to do that? No, I don't want to do that. No, never mind. That would be confusing. So, and it's not in the book, so there's no reason to confuse you. All right, let's go to the next. Let me turn the page. Yep, go ahead. Question? Okay, you're talking about that problem there, Chelsea? Okay. Why did I add another 3? Well, I added another 3. I didn't really have to. In my mind, I know this is 3 forever, right? Like I'm going to change the colors because in my mind, I know that this is really like 3, 3, 3, 3, 3. Would you agree? Would you agree with that, Chelsea? This means repeating, right? So the 3's repeating. It's just going on forever. That's what that means. Okay? So then, but to make it so it's an equal comparison, if I rewrite this and just put like a couple threes there and say, okay, I'm not going to put them forever because I don't have that much time. I'm just going to put a few. Then to compare this side equally to this side, if you need to do that, I can put as many zeros as I have threes. I have this 3 and that 3. Then I have 1, 2, 3. Then I have 1, 2, 3. I'll add another 3 there to make it even. So now I have 5 spots on each side of the decimal counted for. That's all I'm doing. You don't have to do any of that. If I can look at this, with the repeating 3 sign, which is right here, right there. If I can look at that and know that I have a bunch of 3s, then I don't have to put any more on the paper. I can just do it in my head and say that 0.33 is greater than 0.3 or 0.30. You see that? Here? Because if there's nothing there, it's understood to be a 0. Because it's repeating 3. There are no zeros here. It's repeating 3. That 3 repeats forever. Right? Listen, very important that you understand this. That bar there, that bar means that the numbers under that bar repeat forever. It never changes. I can't put a 0 there because it's always going to be a 3. That bar says it will always be a 3. You got that? Does that make sense? Does it make sense now? Great. All right, good. I'm glad you're asking questions. That's good. You like that color? What color was it? Was it a blue color, like the teal blue? Okay, it's still up there. I'll use it again for the next problem. All right. This one here, example 4, and this is our last example and we're done. What time is this class over, by the way? Okay, we got 9 minutes. It wants us to divide. It's asking us, I'll write it down here. It says divide 1.5 by 11. It wants us to divide 1.5 by 11. So I take my, I'll do it over here, 1.5, divide that by 11. And obviously, can I put 11 into 1? No, so I put a 0 here. Bring my decimal up. How about 11 into 15? One time. I have 11, gives me a 4, right? I have to bring down a 0, don't I? Okay, so I'm going to add a 0 here and bring it down. 11 goes into 4 how many times? 3 times. What's my here? 33. 7 left over. I don't have a 0, so I have to bring a 0 down. How many times? 6 times. 66. Let me scroll up here a little bit. Oh, can't lose my answer. I'm going to lose my answer. Okay, so I have a 4. I have to add a 0 and bring a 0 down. What goes up here? Goes down here. Okay, what's left over? 7, right? Do we see a pattern? Got to bring a 0 down. It's 6. Okay, I'm going to move all this over here, okay? I have 0.13636, and I keep on getting this pattern of 70 minus 66 gives me 4. Add a 0, minus 33 gives me 7. You see that you got this repeating pattern here that is producing this repeating pattern over here. So let me change my colors and make this easier. So I keep on I'm getting 0.13636, and as long as I keep on doing it, I'm going to get 363636. It wants me to put a bar over the repeat end. Would you agree that my repeat end is going to be the 3 and the 6? Okay, not the 1, right? Okay, so that's putting the bar over the repeat end. And then it says round to the nearest hundredth. Well, I have to round this to the nearest hundredth. What place is this right here? The tenths. T-E-N-T-H-S, right? What's this? That's the hundredths, so I can put 1 over 100, hundredths, right? T-H-S. That's where it wants me to round to. So my answer is going to be 0.1 something, 4. Absolutely right. Why is that?
Because 6 is up. Because 5 and up is, it goes round up.
5 and up rounds up, so that's going to round that 3 to a 4. You're absolutely right. Good job. Any questions with that? So this was a new bit of information for you guys, huh? How was it? Okay? All right. Turn the lights on for me, and I'm going to turn this off and answer some questions if you have any.